Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called A Few Odd Sums by QQ, and here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or box. We also have region borders divide blue lines into segments. The digits on each segment of a line sum to the same value. Different lines may have different sums. So these are called region sum lines. So for example, these three digits must add up to what these two digits must add up to. This digit must add up to what these two digits must add up to, etc., etc. So as an example, we could have something like, I don't know, 6 and 7. Actually, let's not do that. 6 and 5. And this is, say, 1, 6, and 4. And this works because these two digits add up to 11, and these three digits add up to 11 also. So therefore, these segments add up to the same sum. And that's how an example of how region sum lines work. We also have killer cages, where digits in a cage do not repeat and sum to the value in the top left corner. So for example, these two digits add up to 5, these two digits add up to 15, these two add up to 7, etc., etc. So as an example, if this were 4, this would have to be 5, because those two digits must add up to 9. And that's how killer cages work. And finally, we have digits separated by a white crop key dot are consecutive. Not all crop key dots are given. So for example, if this was a 6, this would have to be 5 or 7 to make sure that these digits are consecutive. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. First things first, I see a couple of digits here. These, particularly, there are 3 unique digits which add up to a single digit here. There are 3 unique digits which add up to a single digit here and here. And I think those are it. Those are the main ones that I see. So anytime you have 3 digits adding up to a single digit, 3 unique digits adding up to a single digit, the single digit has to be 6, 7, 8, or 9, right? Because minimum for 3 unique digits is 1 plus 2 plus 3, which is 6. So this is 6 through 9. These have to be 1 through 6 here. Same here. This is 6 through 9. This is 6 through 9, but it can't actually be 9 here. If this is 9, this would be 0, which is not allowed in a normal Sudoku. So this has to be 6, 7, or 8, which makes this 6, 7, or 8, which makes this 7, 8, or 9. So this must add up to 8 at most. This is 1, 2, or 3, but it has to be 2 unique digits adding up to that digit here. So this must be then a 3, right? Because this is to correspond with the 6, 7, or 8. The 1, 2, or 3 must add up to 9 with the 6, 7, or 8. And since these are 2 unique digits, this is 1 and 2 at minimum, which forces this to be 3, which makes this a 6, this is 6, this is 9. This 3 means this has to be a 1, 2 pair adding up to 3. This 6 means this has to be a 1, 2, 3 pair triplet adding up to 6. These can no longer be 6 here. This cannot be 1 and 6 added together. It can't be 3 and 4 added together. Therefore, this is 2 and 5 added together. We also know in this box, where is the 1? The 1 cannot be in this column because of the 1, 2 pair. And it can't, therefore, it must be one of these digits, which means this cannot be 1 here. This must be the sum of 2 digits, and it cannot contain 1, 2, and 3. Therefore, this must be 4 and 5. That eliminates 4, 5 in the column. Let's see. This cannot be 1, 2, 3, 4, 5. It can't be 6 here. Where is a 6 in the central box? It has to be here. So since this is 6, this is either 1, 5 or 2, 4. But these two unique digits add up to 13. 1 and 2 can never add up with another digit to add up to 13. So this must be 4 or 5, and this is 1 or 2 here. This can't be 3 here. 6 cannot be here. If this is 4, this would have to be 9 to add up to 13. If this is 5, this would be 8 to add up to 13. This is a 7, 8, 9 triplet here. You don't have 6, you don't have 7, 8, or 9 in this cage, which adds up to 11. And you need 3 unique digits. What's the maximum you can have? It's 3, 4, and 5 adding up to 12. But that obviously adds up to 12, so that's not allowed. What else can you have? It has to be 2, 4, and 5 to add up to 11. And that's the only combination that works. Therefore, this is a 2, 4, 5 combination. This 2, 5 is eliminated because of the 2, 5 in the row, so this can't be 2 or 5, so this is 4. Which means this can't be 4 here. This can't be 4. This can't be 1 here, and it can't be 2. So this has to be a 3 here. So this is 3, 4, and 2 here to add up to 9. That's the minimum that was allowed. Therefore, this is 5. 1 cannot be here. So 1 has to be... This 2 eliminates 2 here. So this is 1, this is 5, which makes that an 8 to add up to 13. 1 cannot be here. 1 cannot be here in this box. Where's the 1? It has to be here. We have 6, 7, 8, 9 remaining. So this can't be 6, 7, 8. This can't be 6. This can't be 6 or 9. So this is 7 or 8. The remaining digits here are 1 and 3. In column 5. In column 4, we only have 2, 7, or 8. But this cannot be 2 because if this were 2, that would be 2 unique digits adding up to 2, which is not allowed. So this must be a 2 here. This is 7 or 8, which means this must be either... there's a lot of combinations. Okay, let's not do that one yet. This has to be 4, 5 with 7 or 8 here. This is 1 or 2. What are the remaining digits in row 3? They have to be 4, 7, 8, 9, but this can't be 9 because of this 9 here. This is 4, 7, 8, and 9. If this is 5 and 6, that means this is 11, so this would have to be 4. If this is 5 and 7, that would mean this is 12, but then this would be 5, but we already have a 5 here, so this can't be 7. If this is 5 and 8, this would have to be 2, 5, and 6, but we already have a 6 in the box, so that doesn't work. If this is 9, 5 and 9, that's 14. This would be 2, 5, and this would be 7. So those are the possibilities here. If this is 1, this has to be a 7, 9 pair adding up to 17. If this is 2, it could be 6, 9, or 7, 8. We're not sure which. 6 cannot be here. 6 cannot be here. Okay. This digit is exactly the same as that digit, so it's 4, 5, 7, or 8. And these two add up to 4, 5, 7, or 8. But it cannot be 7. If it were 7, the problem is that these two digits would add up to 7, and these two digits would add up to 7, which is not allowed, because these would then be the same digit. Because this is the same digit no matter what. So these cannot be 7. This is, oh, this is interesting. This is adds up to 15 or 16 here, which means these digits add up to 15 or 16. You can't have a 1 or 2 there. that doesn't tell us very much. Okay, these digits add up to 7. So it's 1, 6, 2, 5, 3, or 4, but this can't be 1 or 2, so this can't be 5 or 6. This can't be 3 here, so this can't be 4. What else do we have? This can't be 8 because of this 8. 6 is one of these 3 cells. 6 can't be here or here, so 6 is one of these 3 cells. Now this is interesting. This adds up to, okay, this is 1, 2, 3, or 4 here. Well, this can't be 2, so this can't be 3. If this adds up to 8, it's 1, 7, or 2, 6 here as a possibility. If this adds up to 7, it's 1, 6, 2, 5, or 4, and 3 here. But no matter what we have, we know one of these 2 digits must have a 1, 2, or 3. Because those are the only... Okay. Let's not go that route. Let's go this route. These 3 digits add up to the same as these 2. This can't be 9 or 8, so this is at most 7. These 2 digits add up to 11 at most. Since these are 11 at most, what's the minimum here? It's also 11. So this minimum must equal the same as this maximum. So they must equal each other. Because obviously this one can't go any lower, and this one can't go any higher, and since they're equal, they must be the same. So this must be a 1-2 pair adding up with 8 to add up to 11. And this is 7 at most, which must add up with 4 to add up to 11. So this must be 1 then. This is either 1 with 6 or 7 adding up to 7 or 8. This 1 eliminates 1 here, so this is 3. This can't be 1, 6. It cannot be 3, 4. It has to be 2 and 5 here, which eliminates 5 here. What else can this be? So this cannot be 1, 2, 3, or 5. If it's 4, this would have to be, actually, we know this is 1. So 1, this can't be 4. If it's 1, 5, this is 6, but that's not allowed, so this can't be 5. We now have a 7, 8, 7, 8 pair in this box, which eliminates 7 and 8 from the rest of the box. This can't be 7 or 8, so this must be 4. This can't be 7 or 8, so this must be 5, which makes this a 5. Therefore, this is 2 and 3 added together. So that's 2 and 3. This 5 eliminates 5 here, so this is 2, which makes that a 5. This 5 eliminates 5 here, so this is 4, which makes that a 5. In row 5, we have a 1, 2, 1, 2 pair, which eliminates 1 and 2 from the rest of the row. So this is 3. This can't be 3. This can't be 3. This has to be 8 or 9 to add up with 1, 7, and 8. But if this is 1 and 7, that would force this to be 8 and that to be 8, which is not allowed. So this can't be 1 and 7. Therefore, this is 1 and 8, which makes this 9. That's a 7 then, and this is 6. The last digit here in row 9 is an 8. This 7 eliminates 7 here. So that's 8. There's no 8 in these 2 cells. Where is the 2 in this bottom left box? Can't be here because of the 1, 2 pair, so it must be here. Where's the 2 in column 2? Cannot be here because of the 1, 2 pair in the box. These are all filled out. This can't be 2 because of that 2, so this must be a 2 here. These digits are consecutive. You can't have 1, 2, or 2, 3 because of the 1, 2 pair in the box. No 3, 4 because of the 4. No 4, 5 because of the 5. No 5, 6 because of the 5 there. This could be 6, 7. It cannot be 7, 8, or 8, 9 because of the 8 in the box. So this has to be 6 and 7 specifically. So this is 6, this is 7, which eliminates 6 and 7 from the rest of the row. Where is the 6 now possible in this box? Can't be here, can't be here, can't be here, so this must be a 6. Therefore, this must add up to 15, because that's the maximum this can be, and that's also the minimum this could be. So this is 9. This can't be 7 or 9, so this is 8, which means this can't be 8. This is 15. That means this is 2, which makes this 1, which makes that 2. This 2 also makes this 1, which makes that 2, which makes that a 1. And we have the 2's filled out. We don't know where the 1 is. Okay. These 3 digits add up to 15. Cannot be 1, 9 because of the 9 in the box. Can't be 2, 8 because of the 2 in the box. Can't be 3, 7 because of the 3 in the box. So this is 4 and 6, which makes this a 4, and this is 6 because of this relatively 4 and 6. This can't be 4, so that's 7. This adds up to 14, which means this adds up to 14, so this is 9, 7, and that makes that 6. This can't be 4, 7, or 8, so this is 9. This can't be 7 or 8, so this is 4. We have 3 and 8 remaining in column 9, so this is 3 because this can't be 8, and this is 8. That leaves this as a 1, 4 pair here. Twos are done. Threes. Where is the 3 in row 7? Can't be here because of the 3 in the box, and these are all filled out, so it must be here. This is a 3. Where's the 3 in row 4? Can't be here, can't be here because of the 3's in the rows in the columns, so it must be here. And we now have 8 3's. We know where the last one is. It has to be here. 4's. Where can the 4 be? 4 cannot be here, cannot be here in this box, so it has to be here. Don't know where the 4 is here, though. 5. Where is the 5 in row 4? It has to be that cell, because this is eliminated by this 5, and these are eliminated by that 5. That leaves, we have 8 5's. We know where the last one is. It has to be here. 6's. Where is the 6 in column 1? Well, can't be any of these, because this sees that 6, this sees that 6, so this is a 6 here. And that, actually, this is, yeah, it's the 8th, that's the 9th one, 6, so that's fine. Where is the 7 in row 2? It has to be here. Where is the 7 in row 8? Can't be here, so it can only be here. Which leaves, where is the 7 in... Actually, that doesn't tell us anything. So that's 7. What about 8's? We know where the last 8 has to be here in column 3. And in row 5, it has to be here, which leaves, we have 8 8's now. We know where the last 8 is. It's here. And that leaves 9's. We know 9 has to be here, and it has to be here, which makes this 7, which makes that a 9. That gives us all the 9's. 1's can only be here, which makes this a 4, which makes that a 1. That leaves this as a 7 and this as a 4. And that's how you solve it. Yeah, pretty straightforward use of region sum lines in cages. Obviously, you have certain limitations here, which forced certain patterns that you have to go down. Yeah, pretty straightforward. Anyways, I hope you enjoyed this solve, and I'll see you next time on Learn How to Sudoku. Take care.